Now let us discuss about how to solve a differential equation by using a variable separable method. Okay, in this method, first of all, an ordinary differential equation of the first order and first degree of the form of, what is the form of first order and first degree? It is dy by dx plus f of xy equals to 0. So do you know here what is f of xy? In f of xy, the product of two terms, it's x and y. So it can be conveniently written as same as well as it is m dx plus n dy equals to 0. Here m and n are functions of x and y terms. Here m and n are both are x and y functions of x and y terms are constants. Now we do, first of all, what is the first order and first degree formation dy by dx plus f of xy. It conveniently will be written as m dx plus n dy is equals to 0. After we do that, separation of variable, then we will get f1x dx plus f2y dy equals to 0. After this process, we will on integration above equation, we will get integration of f1x dx plus f2y dy equals to constant. Here, which is the solution of above given differential equation. So how to solve a differential equation by using a variable separable method? In this we remember it 3 steps. First of all, it is form of dy by dx plus f of xy equals to 0. Other than it is form of m dx plus n dy equals to 0. Then after we do the process separation of the variables, what we will get? It is f1x dx plus f2y dy. Then after after do the process on integration of above equation, what we will get? Integration of f1x dx plus integration of f2y dy is equals to 0. This is the using of variable separation method we can solve the variable separable method of differential equation. Here one example solving of by using variable separable method of given differential equation. What is the given equation? X dy equals to x dy minus y d equals to 0. So it is the solve of differential using by variable separable method. So x dy minus y d equals to 0. First of all, we written given equation form. So how to solve a variable solving method? We remember 3 steps. First it is form of dy by d equals to function of x comma y. Other than m dx plus n dy equals to 0. It is given of, it is form of m dx plus n dy equals to 0. So x dy plus x dy minus y d equals to 0. Here we can write it x dy equals to y dx. So here left hand side term is x dy and right hand side term is y dx. Here y and x and are also mixed terms. Here y and x are also mixed forms. So we are interchanging of variables. That is, we will get dy by y minus dx by x equals to 0. Then other than we can write it same as well as dy by y is equals to dx by x. So it is form of after completed of separation variable. Then what will do the next process on integration of above equation. So here integration of 1 by y dy minus 1 by x dx is equals to constant. After integration 1 upon y dy integration, what will get? Log y minus after 1 by x dx integration log x is equals to log c. Here log m minus log mn. So that's we can write it log xy is equals to log c. So both are log cancel. Then what is the remaining term? Xy is equals to 0. Next we will move on another example of differential equation by using a variable separable method. So what is the given equation? What is the given equation e to the power of y plus 1 into cos x dx plus e to the power of y sin x into dy equals to 0. So this equation can solve by using variable separable method. So first of all, what we will give in the equation can be written as it is e to the power of y plus 1 cos x into dx plus e to the power of y sin x dy equals to 0. So as we can separation of variable, after separation of variable, so it can write be cos x by here sin x into dx plus e to the power of y by e to the power of y plus 1. So here is cos x, here is sin x. We can write it cos x by sin x into dx. Here is e to the power of y and here is e to the power of y plus 1. So we can write it e to the power of y by e to the power of y plus dy. So you will observe here, it is separation of variables in xn terms and dx terms and it is dy terms. After interchanging variables, then what will next step? We will move on integration. Integration of cos x by sin x into dx plus integration of e to the power of y by e to the power of y plus dy equals to 0. So here apply one formula. What is that formula? Integration of f derivative x by f of x is equals to log f of x. Please see. So and here function of x is equals to derivative of numerator term. So what we'll get? It is log of f of x. So this formula can apply this above integration process. Here denominator term is sin x. Sin x differentiation is cos x. So we can apply this formula. So here f dash x by f of x equals log of f of x. So that's right, we can write it log of f of x. F of x means sin x. So that's we can write it log sin x plus same implementation of this process also. Similarly, e to the power of y plus 1, e to the power of y by e to the power of y plus 1 into dy. So e to the power of y differentiation also e to the power of y. So that's why we can implement this formula. So plus log of log of f of x, log of f of x. So that we will take log of e to the power of y plus 1 equals to log c. Here same log m plus log n. So what is the formula of log m plus log n? It is log mn. So that's why we can write it log m into n. So log e to the power of y plus 1 into sin x is equals to log c. Both are log terms cancel. Then e to the power of y plus 1 into sin x equals to 0. This is the solution of the given differential equation, solving of by using. Now let us discuss about homogeneous differential equation. So first of all, do you know what is homogeneous differential equation? So first of all, we will take general notation of the homogeneous differential equation, that is z is equals to f of x comma y. So it can be written as z is equals to a0 x to the power of n, a1 x to the power of n minus 1 into y plus a2 x to the power of n minus 2 into y plus so on a to the power of n x to the power of n. So we will observe in this equation. So in this term x to the power of n term is common. So now we will take x to the power of n common. After we will take x to the power of n. So what will get remaining terms? In this first term x to the power of n is common. Then what is remaining term? a0. So that's why we can write it a0 plus here what is second term? a1 x to the power of n minus 1 into y. a1 x to the power of n minus 1 into y. So here x to the power of n minus 1 we can write it x to the power of n into x to the power of minus 1. So here x to the power of n we can write x to the power of n into x to the power of minus 1 we can write it 1 by x. So after we will take x to the power of n, what is remaining term? a1 into y by x plus a2, same as well as this process implementation of next term also. Then what we will get? a2 y by x all to the power of 2 plus so on a to the power of an of y by x all to the power of n. So in this equation, what will we observe? It is y by x all to the power of n, y by x all to the power of 2 plus so on y by x all to the power of n. So this is general notation. We write it z is equals to x to the power of n y by x. It is general notation of the homogeneous differential equation. So now let us discuss about how to solve of homogeneous differential equation. So now we will take two functions, that is pi of x comma y and psi comma x comma y. Next another function psi comma x comma y. It is as well as we write it z is equals to x to the power of n of y by x. It is general notation of homogeneous differential equation. So first of all, it is given differential equation can be write it m dx plus n dy equals to 0. Then it's said to be homogeneous. It is said to be homogeneous. Homogeneous means a differential equation involving each and same term, each degree is same. Okay, homogeneous means in given differential equation each and term is degree same. So now how will we take two functions, that is pi of xy and psi of xy. We can write it dy by dx equals to pi of xy by psi of xy. So it is homogeneous. What is general notation of homogeneous? Is equal x to the power of n by y by x. But here we will take two functions, that is pi of xy and another function psi of xy. Here pi of xy and psi of xy are homogeneous function of the same degree. So both are same degree of in functions x and y. So the next step is pi of xy is equals to, we take x to the power of n function of y by x. Then psi of xy is also x to the power of n g to the power of y by x. Here also we will take f, that's why we can change it x to the power of n g y by x. This is both are general homogeneous differential functions. Here f and g are functions of real variable. So next we will what will you do the process? It is dy by dx. So dy by dx equals to, what is pi of x? Pi of xy equals to x to the power of n f of y by x. So that's why we can write it x to the power of n function of y by x. Next, what is psi of xy? Psi of xy is equals to x to the power of n g of y by x. So x to the power of n g y by x. After we will do the process, we get something value. So that is notated h of y by x. So that is equation 2. So above equation can be solved by using. So how will we solving by the above equation? So it is h of y by x. So in this y place we substituted vx. Then y is equals to vx. Then we will get differentiation with respect to x. What we will get? Differentiation dy by dx equals to v plus x into dv by dx. Then what is the value? Dy by dx is equals to v plus x into dv by dx. This value substituting in the above equation. So dy by dx is equals to h of y by x. But dy by dx is, we know the value, v plus x into dv by dx. We substituted value v plus x into dv by dx equals to h of here y by x. In this y is equals to vx, we can write it y by x is equals to v. So that's why we write it h of y by x is equals to h of v. Next we do the separation of variable. So after separation of variable we will get dv by d by h of v minus v. Next, I will explain one example of how to solve a differential equation by using of homogeneous differential equation. So observe this example. X square minus y square into dx plus 2xy dy equals to 0. So first of all we solving of the differential by using of homogeneous method. We remember it three things. So first of all, it is homogeneous or not. So first of all, observe it. It is x square minus y square. Both are degree have 2. So first term degree have 2. Then next term xy. So this term is also 2. So this is homogeneous function. So after we observe the homogeneous function, we will move on. We substitute y is equals to vx. So first x square minus y square into dx plus 2xy dy equals to 0. So this equation we can be written as dy by dx equals to, in this equation we can write it minus common, we will take minus common, y square minus x square, y square minus x square into dx equals to, it is minus 2xy dy, minus 2xy dy. So it is minus cancel. Then it is change of dy by dx. So it is dy by upon dx equals to, it is y square minus x square by 2xy. It is y square minus x square by 2xy. So this put in equation 1. So next it is also dy by dx is equals to y square minus x square by 2xy. It's homogeneous function. So after homogeneous function, how to solve of that above equation? We put in y is equals to vx. So that's why we will take y is equals to vx of differentiation with respect to x. So what we will get, dy by dx equals to v plus x into dv by dx. So here dy by dx value is substituting above equation. So in place of dy by dx, we substitute in v plus x into dv by dx. What we will get, v plus x into dv by dx equals to y square minus x square by 2x. So v plus x into dy by dx equals to here y. But what is y? Vx. So in place of y value substituted in vx. So that's why we can write it v square x square minus x square by 2x. Y means vx. V plus x into dy dv into dv by dx equals to, here both are x square term common. So we will take x square common. So then what we will remaining terms, v square minus 1 into x square by 2 into v of x square. So x square cancel. So the remaining term is v square minus 1 by 2v. Then next here is plus v. If transport right side, it is minus v. So then what we will get, x into dv by dx equals to v square minus 1 by 2v minus v. So x into dv by dx equals to, where we will take LCM. So what we will get, v square minus 1 by 2 minus 2v square by 2v. X into dv by dx equals to, here is plus v square and minus v square. So here is minus v square by minus 1 by 2v. So we will take minus common. So after that, v square plus 1 by 2v. So here is observe both are two variables, that is x and v. So now we will do the separation of variables. After of separation of variables, we will get 2v by v square plus 1 into dv equals to, here is minus, here is x dx by minus dx by x. After separation, we will solve of above equation by using on integration of above equation. Integration of 2v by v square plus 1 into dv minus integration of dx by x plus c. So what is the formula of integration of 2v by v square plus 1 into dv equals to, here is apply one formula. What is that? Integration of f of x by f derivative of x by f of x is equals to log of f of x. That's why we can write it v square plus 1 derivative 2v. So that is numerator term. So what is the differentiation of v square plus 1? It is integration, it is 2v. So that's why we can take log of f of x. So log of f of x means v square plus 1. So that's why we can write it log of v square plus 1. Log of v square plus 1 equals to 1 upon x. What is the integration of 1 upon x into dx? It is minus log x plus log c. So it is log of v square plus 1 equals to, here is log m minus log n. So that's why we can, if minus log x, it is transport right side. So log of x square plus 1 plus log x is equals to log c. So here is log m plus log n. So that's why we can write it log of x into v square plus 1 equals to log c. So both are log cancel. What is remaining term? X into v square plus 1 equals to c. But v is equals to, we can write it y is equals to vx. So y by x equals to v. So we substituted in v y by x. So that's why we can write it x of v means y by x. Here is v square. So that's we can write it y square by x square plus 1 equals to c. So here is x square common. So x of x square plus y square by x square equals to c. So x term cancel. Then remaining term is x square plus y square equals to, here is denominator x. If transport it is left x, multiplication x. So what we will get, x square plus y square is equals to cx. It is solving of above differential equation. So this session we completed. What we will learn about what is differential equation and order and degree of the differential equation, and how to solve of the differential equation by using of separation variable method and homogeneous differential equation method, and application of where we use of differential equation in many fields. So that's why we know the applications of differential equations. I hope you understand my class. Thank you for watching. Thank you.